Let's say you have a fraction, a over b, and you want to divide it by c over d. Well, that's equivalent to a over b times d over c. Notice how we took the reciprocal of c over d to get d over c. Now, this definition of dividing fractions only applies when b, d, and c are not equal to 0. If there were 0, we would get an undefined value. So let's do some examples. We have 4 over 5 divided by 5 over 16. Now this is equal to 4 over 5 times the reciprocal of 5 over 16, which is 16 over 5. If we multiply things out, we get 64 over 25. Now 64 and 25 are both composite numbers, so we might think we need to simplify the fractions. However, if we dig deeper, we will see that the numerator and the denominator have no common factors. So 64 over 25 is the simplified fraction. Let's do another example. 5 over 12 divided by 15. This is the same as 5 over 12 times the reciprocal of 15, which is 1 over 15. If we multiply things out, we get 5 over 180. Now, if we use our understanding of prime and composite numbers, we can see that 5 is a prime number, so we'll leave the numerator as is. Now, the composite number 180 can be written as 3 times 3 times 2 times 2 times 5. Now, if we use our understanding of the fundamental principles of fractions, we can cancel out the 5's and we're left with 1 over 36, which is the simplified fraction for 5 over 180. Finally, we have 7 over 6 divided by 7 over 15. This is equivalent to 7 over 6 times the reciprocal of 7 over 15, which is 15 over 7. If we multiply 7 times 15 divided by 6 times 7, we get 105 divided by 42. Now 105, written as a product of primes, is 7 times 3 times 5, and 42 can be written as 2 times 7 times 3. At this point, we can cancel 21 from the numerator and the denominator, and we'll be left with 5 over 2, which is the simplified fraction for 105 divided by 42.